A very good morning. I'm Shantini Katiravan and my matrix number is 33DCE21F1054. Today, we will be conducting the Izod impact test. The objective of the experiment is to find the impact resistance of mild steel and cast iron. The apparatus used are impact testing machine. Now, let us move on to the procedure. Step 1. Select the Izod test specimen. I would like to choose mild steel. And here are few characteristics of the milestone, which is the length, breadth, depth of notch. Step 2. Test for friction loss is conducted by adjusting the pointer to 164 joules. Then the pendulum is released by operating the lever without keeping the specimen. The loss of energy due to friction EF equals to 2 joule. Step 3. The Izod test specimen as per Indian standards IS 3766 to 1977 is placed in position. Trial 1. Here are few description of the apparatus given, which is this is known as the supports, and this is the angle between underside of striker and face of test piece, and this is the direction of impact, and this is the angle of tip of striker, and here we can see the radius of curvature of striking edge, and this is the test piece, and this is the striking height. Step 4. The pendulum is released. The hammer strikes against the specimen, breaks it, and swings further than the observation is noted down. And remember, this is for the trial 1. We can see that the test piece was not broken by striking energy of the test machine, so the impact value obtained is indefinite.
Hi, my name is Nur Sufian Salam. My matrix number is 33D81F1034. For trial 1, initial energy of the hammer equal to 164 joule. Average loss of energy due to friction EF equal to 2 joule. Total loss of energy ET during transit of hammer equal to indefinite. And energy of failure of specimen equal KU over impact value equal ET minus EF equal to indefinite.
Now, trial 2. We're going to repeat the same instructions given by using the same specimen, but we will be taking 3 trials. We have to repeat the same procedure again. Here we can see the total loss of energy during transit of hammer ET equals to 46 joule, and energy for failure of specimen ET minus EF equals to 44 joule.
For trial 2, initial energy of the hammer equal to 164 joule. Average loss of energy due to friction EF equal to 2 joule. Total loss of energy ET during transit of hammer equal to 46 joule. And energy of failure of specimen equal KU over impact value equal ET minus EF equal to 44 joule.
And now, trial 3. We have to repeat the same thing again. After releasing the pendulum, we can see that the total loss of energy during transit of hammer ET equals to 41 joule, and the energy for failure of specimen ET to EF equals to 39 joule.
And last for trial 3, initial energy of the hammer equal to 164 joule. Average loss of energy due to friction EF equal to 2 joule. Total loss of energy ET during transit of hammer equal to 41 joule. And energy for failure of specimen equal KU over impact value equal ET minus EF equal to 39 joule. So there are 3 observations of milestone. So average energy for failure of specimen equal to 41.50 joule.
Now, we have to repeat the same experiment using the same objective and same apparatus, but different Izod test specimen. We will choose the cast iron now. As we can see, the length of the cast iron is 75 and the breadth is 9.3 mm and depth is 9.4 mm. Meanwhile, the depth of notch equals to 4.2 mm. Step 2. Test for friction loss is conducted by adjusting the pointer to 164 joules. Then the pendulum is released by operating the lever without keeping the specimen. The loss of energy due to friction EF equals to 2 joule. And step 3, The Izod test specimen as per Indian standard IS 3766 to 1977 is placed in position. We're going to do the trial 1. The pendulum is released. The hammer strikes against the specimen, breaks it, swing further, then the observation is noted down. As we can see, the total loss of energy during transit of hammer ET equals to 10 joule. Meanwhile, the energy for failure of specimen ET minus EF equals to 8 joule.
For trial 1, initial energy of the hammer equal to 164 joule, average loss of energy due to friction EF equal to 2 joule, total loss of energy ET during transit of hammer equal to 10 joule, and energy for failure of specimen equal Ku over impact value equal ET minus EF equal to 8 joule.
And again, we have to repeat the procedures to get result for trial 2 and trial 3. For trial 2, we can see the total loss of energy during transit of hammer ET equals to 5 joule and the energy for failure of specimen ET minus EF equals to 3 joule.
For trial 2, initial energy of the hammer equal to 164 joule, average loss of energy due to friction EF equal to 2 joule, total loss of energy ET during transit of hammer equal to 5 joule, and energy for failure of specimen equal Ku over impact value equal ET minus EF equal to 3 joule.
And again for trial 3, the total loss of energy during transit of hammer ET equals to 6 joule and the energy for failure of specimen equals to ET minus EF which is 4 joule.
And last for trial 3, initial energy of the hammer equal to 164 joule, average loss of energy due to friction EF equal to 2 joule, total loss of energy ET during transit of hammer equal to 6 joule, and energy for failure of specimen equal Ku over impact value equal ET minus EF equal to 4 joule. There are 3 observations of cast iron. So, average energy for failure of specimen equal to 5.00 joule.
My name is Praveen. My matrix number is 33 DCE 21F1101. The results by differentiate between mild steel and cast iron. Cast iron has a lower melting point than mild steel because it can be very well be solidified by heating and sudden cooling. Mild steel materials are ductile. The malleability of mild steel is more than cast iron. Cast iron is not ductile. Mild steel is stronger than cast iron in both tensile and strength, yet cast iron is modestly contrasted with mild steel. Cast iron has great damping properties than mild steel. This is the thing that makes cast iron is the best material for bed clips and surface tables. Mild steel is brittle where cast iron is not brittle. Conclusion. To conclude that Izod impact test is test used in studying the toughness of material. Toughness is connected with both ductility and the strength of material. An impact test involves in the sudden and dynamic application of the load. In this test, we will see the response of material under dynamic loading. An impact loading applied to the specimen as cast iron and mild steel. This will be also as a general idea about brittleness and ductility change with respect to temperature. Recommendation. This Izod impact test is really important, especially if the material shall be used in construction, which we need to test in the materials to know its capacity.